All right. What is going on here? Okay, so I had to make a part 2 of this because I just realized that the video I did previously did not capture all the code or the whiteboard that I've done. Whiteboard. Don't delete it. I deleted it. That sucks. Okay, so I'm just gonna go over this because this is what we have. Unfortunately, I'm sorry guys. Shit happens, and I'm still gonna post it because I'm gonna post my failures. I don't care. All right. Feel free to dislike it. I don't care. It's going up. I did not spend the last 50 minutes trying to do this to not post it. Okay. So combinations, possible letters, backtracking. So we don't need editor tools. As you can see, this solution passes all the test cases and it passes the submission. So basically, according to the description, you can have 0 to 4 digits in length. If it's 0, return an empty array like we do in example 2. Otherwise, map all this stuff here, map all the digits and letters, map all the digits here. So as you can see, here's where the digits are and the corresponding letters. So 2 is ABC, 3 is DEF, 4 is GHI, so on and so forth. Combination is where we will store all the combos that we're building. Next, we create a helper function called backtrack. So we're going to use recursion to solve this problem using recursive backtracking. And it uses the index and the path. All right, so the index is basically the first letter in the path that we're building. So if the index is equal to the length of digits, then we append the path because we know we're done. We know we're finished iterating through everything in that index list. The index of that list, right? So string is also a list. So what's happening is we have to build a path as it goes. So possible letters is stores digit index. So stores digit is this, and index. So stores digits, boom, index. So digits is the input string. So let's say it's 2, 3. And index would be the index at 0. As you can see, we started at 0. So the index of 0 is 2. 2 in stores is ABC. All right, so for letter in possible letters, so possible letters is now ABC. This does recursive backtracking and a path for ABC. So backtrack, boom. It's going to be A with index plus 1. Right, so it's going to be A with index plus 1. So this is going to come here, and then it's going to go through the next one, because index plus 1 is 1, because the first one was 0. So now it's going to be 3. 3 is DEF. It's going to be A, and then path plus letter. So now this already has an A from the last one, and now it's going to be D. Then it's going to be A, and E, and A, and F, right, for each letter in the possible letters. So A, because it's going to backtrack, because it's going to go D. So A is the path that's already built. Right, A is the path that's already built, and it says when index equals len digits. Right, so index is 0. Now it's 1, right? And now we append D, because this is already at A, right? So AD, then we go again. Equals this, so just append whatever's there. So AD gets appended. Then it's E, because we still go back, because it's still on 3. So E, we feed it back in. There's nothing after that, so we add AE, then we go back. F, then we go back. After F, right, we have to go back to 2, right? The current path was A. So now we're going to go to B. So B, then we add the index plus 1. Now it's at 3. B and D, B and E, B and F. Same thing. Now we go back to 2. Boom, C. Now we go back to 3. C and D, C and E, C and F. Now we go back to this, right? And then we break out of that loop. We finally get through the iterations, and all these paths are appended. So by the time you call this, it calls the backtrack, goes to all the possible combinations. Comb is filled, because every time you hit a combination and it hits length digits, so A is just one letter, right? But when you go AD, that's 2 letters. 2 is equal to length digits, add it. AE, AF. So you get all the combinations built, and then you just return that array, right? Because it keeps going until that path is built. The path is the substrings that we're trying to build. The substrings that are equal to the length of the digits. So if you look here, length is 2, so each substring is 2. Each combination of strings is 2. If you look here, 0, so no combinations. If you look here, 1, so each string is 1, right? And then based on the letter that you use, or the number that you, based on the number that you use, you get the corresponding letters. So as you can see, passes all the test cases, and it passes the submission, and it beats 44.37% of other solutions. So yeah, if you like that video, please give it a thumbs up, subscribe, comment below. I don't know what happened in the last video. For some reason, the screen record did not capture me typing this out, and my whiteboard, when I came back to it, refreshed everything. And this is just an explanation of all the concepts here. That way we don't have to, I'm just gonna slowly scroll through it so you can see. Boom, boom. This is a line by line. Sorry guys, this is one of those cases where the video just failed, so this is the best I could do. I don't want to have to record a 1-hour session again. These are all done live, so because of that error, yeah, all that video where I type out the code and explain is lost, so I could only give you a high-level summary in the part 2. All right, once again, I apologize. Knologist out.